Calculus 1 Final Exam Review, Problem 9. Y equals 12 is a constant function. Therefore, its derivative is 0. That is, dy dx equals 0. In part B, let's rewrite this function as a sum and difference of power terms. Now we can write its derivative. G prime of t is equal to negative 3 times 2 is negative 6 t raised to the 1 power, decreasing that exponent by 1. Then negative 4 times negative 3 is positive 12 t raised to the negative 4, as this negative 3 minus 1 is negative 4. The derivative of 2t is 2, and the derivative of this subtracted constant term is 0. Simplifying, we write negative 6t plus 12t to the negative 4 plus 2. Notice that I did not write an equal sign, as I see students do so often, between the function and its derivative. They are not equal. They are two different functions. We do not put an equal sign between them. For the form of an answer that looks a little bit more like the original, we could write negative 6t plus 12 divided by t to the positive 4 power plus 2. In part C, we cannot take the derivative of the numerator and then divide by the derivative of the denominator. Totally wrong. Now we could use the quotient rule, but there is a simplification that we can do first that will avoid the quotient rule. The denominator has a single term which we will distribute across the subtracted and added terms of the numerator. Simplifying, we get x minus 3 plus 4 times x to the negative 2 power. Now let's take the derivative. The derivative of x is 1. The derivative of a constant is 0. We use the power rule. 4 times negative 2 is negative 8. X raised to the negative 3, which is negative 2 minus 1. We can write 1 minus 8x to the negative 3. We can write 1 minus 8 divided by x to the third. I'm sure most instructors would consider that a sufficient answer. But if we were to match the original form, which is of a single fraction, we would have to get a common denominator, which would be x cubed. And multiplying 1 by x cubed divided by x cubed, we could write x cubed minus 8 all divided by x cubed. Part D is a difference of power functions. We have x raised to the 1/2 power minus 6 times x raised to the 1/3 power. The derivative is therefore 1/2 x raised to the 1/2 minus 1 minus 6 times 1/3 x raised to the 1/3 minus 1. We have 1/2 x to the negative 1/2 minus 2x to the negative 2/3. Hopefully I don't have to explain basic fraction work to you, but you can double check that on your calculator. An answer that is back in radical form, matching the form of the original function, we would write 1 divided by 2 times the square root of x minus 2 divided by x to the 2/3 power. And the 2/3 power is the cube root of x squared. Let's rewrite the function in part E as h of x equals x to the negative 1 minus 12 secant of x. Its derivative, h prime of x, is equal to negative 1 x to the negative 2, that's what you get when you take this negative 1 and subtract 1, minus 12 times, the derivative of secant of x is secant of x times tangent of x. So we have negative 1 divided by x squared minus 12 secant of x tangent of x. In part F, we have f of x equals x times sine of x. Very important to notice that this is a product. The derivative is not the derivative of x times the derivative of sine of x. That is not the derivative. When you have a product, you find the derivative by the product rule. The derivative of the first factor times the second factor. Reverse the roles plus first factor times the derivative of the second factor. We have 1 times sine of x plus x times cosine of x. Our answer is sine of x plus x times cosine of x. In part G, we rewrite this as 6x squared plus 1 raised to the 1/3 power. We see that we have a composition, so we will find the derivative by the chain rule. The outside function is a power function, so we use a power rule, 1/3, and then the same inside function raised to the 1/3 minus 1, which is negative 2/3. Again, it's the same inside function. That is not changed. But that's also not the end of the story. We then multiply by the derivative of that inside function. So we have 1/3, 6x squared plus 1 to the negative 2/3 times 12x plus 0. This 12 divided by 3 is 4, and we can write 4 times x divided by this quantity adjusted to the denominator in radical form, which would be cube root of 6x squared plus 1 quantity squared. That's the answer. To take the derivative of the function in part h, we again must use a product rule because we have the product of two factors here. dy dx is equal to the derivative of x squared times e to the negative x plus x squared times the derivative of e to the negative x. The derivative of x squared is 2x, and the derivative of e to the negative x by the chain rule is e to the negative x times negative 1. This is a composition, and this derivative required the chain rule. We have 2x e to the negative x minus x squared e to the negative x. Some instructors, some textbooks require a factored answer. Let's do that. The greatest common factor of these two terms not only includes e to the negative x, but also a factor of x. X times e to the negative x multiplied by 2 minus x, as this x times x would give us that x squared. Here in part I, we will have to use the chain rule to get this one going. Now recall that the derivative of the natural log of x is equal to 1 divided by x. So the derivative of our function here will begin with 1 divided by this inside function. The chain rule says we then have to multiply by the derivative of that inside function. Let's write that formally. Now taking the derivative here, because it involves a quotient, will require the quotient rule. Let's do that task separately and then bring this other complex fraction factor back into our answer. By the quotient rule we have the derivative of the numerator times the denominator minus numerator times the derivative of the denominator, all divided by the denominator squared. Let's look at this derivative. It's a sum. The derivative of 1 is 0. The derivative of e to the x is e to the x. That's multiplied by 1 minus e to the x. And then this derivative has a minus sign. Derivative of e to the x is e to the x. Let's clean up that numerator. Distribute this e to the x through here. We have e to the x minus e to the x quantity squared. And e to the x times e to the x, or e to the x quantity squared, is e to the 2x. Multiplying with the same base, you add the exponents, and x plus x is 2x. Here we have negative 1 times negative e to the x. That gives plus e to the x. Then we have a negative e to the x times a negative e to the x, giving us positive e to the 2x. These two terms are opposites and add to 0. These other two terms are like each other. We add their coefficients 1 and 1 and get 2. So we have 2 e to the x divided by 1 minus e to the x squared. We need to bring this down here. 1 divided by a quantity is the reciprocal of that quantity. Now bring in our quotient rule result. And then just like a quantity, a divided by a squared is 1 divided by a, likewise this factor and this factor divide, leaving us power 1 in the denominator. So our final answer is 2 e to the x divided by 1 plus e to the x, 1 minus e to the x.